In section 6.5, we get into proving triangles are similar by side, 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 and side, angle, side similarity. So the question we have is, how can we prove triangles are similar? And I should say, what other ways can we use to prove triangles are similar? Because we already covered angle, angle similarity. So side, side, side similarity theorem says that if all the corresponding lengths of two triangles are proportional, then the triangles are similar. So for example, if AB over RS is equal to BC over ST, and that's equal to CA over TR, then the triangles are similar. So let's talk about what that means. An example one says use side, side, side similarity to see is either triangle DEF or GHJ similar to triangle ABC. So what we gotta do is find out all of the ratios of the sides. So let's first look at the smallest sides. So we're gonna do triangle ABC over triangle DEF. And let's start with the smallest sides. Not smallest, the smallest sides. So the smallest side for triangle ABC, the smallest side is 8. So it'd be 8. And the smallest side in DEF is 4. So 8 over 4 is equal to 2 over 1. Then we have to do the medium side. The medium side in triangle ABC is 9, and the medium side in DEF is 6. So we would do 9 over 6. 9 over 6 is equal to 3 over 2. 3 over 2 is not equal to 2 over 1. You see how those two are not equal? So they're not similar. Because if they were similar, all of the ratios would be equal. So now let's try, how about triangle ABC over triangle GHJ? And let's start with the smallest sides. The smallest side in ABC is 8. The smallest side in GHJ is 16. So 8 over 16, which equals 1/2. So it reduces down to 1/2. The medium side, or the middle side, is 9 in triangle ABC. And the middle side in GJ is 18. So 9 over 18, which also reduces down to 1/2. And then we got to do the large side. The large side is AC and 24. So it would be AC is 12 and JG is 24. And this also reduces down to 1/2. So what we found out is triangle ABC is similar to triangle GHJ by side, side, side similarity. So the three sides are proportional. All three pairs of sides are proportional in the smallest and biggest triangle. Example 2. Find the value of x that makes triangle ABC similar to triangle DEF. So first, we have to know that the corresponding sides are what they are. So AC, so we have AC matches up with DF. Notice A and C are first and third, so is D and F. And that's going to be equal to AB over DE. AB and DE are first and second. And then we have BC over EF. So those are all proportional. They would all be equal to each other. So now we have to figure out, we're solving for x. So AB is x minus 3. So if we fill that in, we would have x minus 3 in for AB. DE is 20, right? BC is 4. So we'd have 4. And EF is 10. So we would do x minus 3 over 20 equals 4 over 10. And all we really need is 2 of the fractions. We don't need all 3. We have enough now to solve for x, because we can cross multiply. 20 times 4 is equal to 10 times x minus 3. And notice I did put parentheses around the x minus 3, because if I don't, I tend to forget that I have to distribute this 10. So we'll have 10x minus 30, where a lot of people would write down 10x minus 3, but it should be 10x minus 30. And 20 times 4 is 80, so 80 equals 10x minus 30. So we're solving for x, we have to add 30, and we get 110 equals 10x. And then we divide by 10 to get x equals 11. So if x equals 11, that would make the triangle similar. And again, we did that by setting up a proportion. All right, so we got some checkpoints. Explain how you would determine which of the 3 triangles are similar. So how we determine this, we would do side, side, side similarity by showing all ratios of corresponding sides are congruent or are equal. So how we explain or how we determine, we have to do side, side, side. So it'd be the 2 small sides and the 2 medium sides and the 2 biggest sides. If all those form equal ratios or congruent ratios, then they're similar. And it just says to explain how we would do it. It doesn't say that we actually have to do it. So number 2, suppose that AB is not given in triangle ABC. So suppose that this length over here was not given. What length of AB would make triangle ABC similar to QRP? So in other words, let's call AB X. So we would have AB over QR, and that would be equal to BC over RP. Okay, and I just got that from the order. AB and QR match up, BC and RP match up. So they're saying, what if AB were X and we didn't know it? QR is 30. BC is 42. And RP is 35. So we would cross multiply that, and we would get 35 times X equals 42 times 30. So 35x equals 42 times 30 is 1,260. And then we divide by 35. X equals 36. So if X were 36, then the 2 triangles would be similar. So that would be side, side, side similarity. All 3 ratios of the corresponding sides are equal. The next one is side angle side similarity, where one angle of a triangle is congruent to an angle of another triangle, and the lengths of the sides, including these angles, are proportional. So if you see the angles that's marked, the angles that are marked, these sides that are making up that angle, that are including that angle, those are the sides that have to be proportional. Okay. So let's go through a couple examples. It says, you are drawing a design for a bird feeder. Can you construct the top so it's similar to the bottom using the angle measures and lengths shown? So we're trying to see, can we make these similar triangles? You see how the top triangle is bigger than the bottom. So if we look, each angle is 87. So 87 and 87. All right. Now, if we look at the side lengths, the two sides in the top triangle are 32, and the two sides in the bottom triangle are 20. So what we have right here is angles are both 87 degrees. Okay. Now, if we set up the ratios, the ratio we use would be big over small, big triangle over small triangle. So we have 32 over 20. Is that equal to 32 over 20? This is true. So those two fractions or proportions are equal to each other. 32 over 20 does equal 32 over 20. So we have side, and then we have the angle that's in between. Side, angle, side. So side, angle, side. Similarity is the reason why, because we have one angle and then the two included, or two sides that included angle, are both proportional. So are they similar? Yes. Checkpoint 3, in example 3, suppose you use equilateral triangles in the top and bottom. Are the top and bottom similar? So we had equilateral triangles. So let's say we have two triangles. One is bigger, one is smaller, but they're both equilateral. Okay? The easiest way I can think of is, if it's equilateral, what do you know about it? Well, we know that all the sides are equal, and all the angles are going to be 60, because all the angles have to be the same. So if all the angles are 60, because 60 plus 60 plus 60 is 180, that means they'd be similar by angle similarity. So the answer is yes, angle similarity, because we have one pair of angles, and then we have a second pair of angles that will be congruent. So it'd be angle similarity. All right, and then the last box here, triangle similarity postulate, just says that we know angle similarity is what we covered previously. Side similarity is what we talked about earlier today, and then side similarity is the last one. And it kind of just justifies how you would know that. Angle is two angles. Side is you have to know all three sides are proportional ratios. And then side would be, you know one angle, and you know that two sides surrounding that angle are proportional. So in example 4, it says, tell what method you would use to show that the triangles are similar. Well, what we know right here is we know that we have one length here and a second length in the triangle on the left, and we know two of the lengths in the triangle at the right. So we know two side lengths. We have two S's. Okay? Do we know anything about the angles? And the answer is yes, we do. We know that we have vertical angles. So this picture gives us side and a side and an angle. So what we have in each triangle is side, angle, side. So since we have the vertical angles, okay, vertical angles are congruent, and we know two of the sides, so we would use side, angle, side, because vertical angles are congruent, and we are given two side lengths. So vertical angle is congruent, we're given two side lengths. The method we would use is side, angle, side, because we can't use angle, and we can't use side, side, because we don't know enough information. So it'd be side, angle, side. And And then checkpoint 2, explain which method you would use to show that triangle JKL, so J to K to L, is similar to L to K to M. So if you look at this picture, if I zoom in on the red one, the red triangle, we do know 3 sides, a side, and a side. We also know the 3 sides in this green triangle. So what method will be used to show these triangles are similar? We would use side, side, side similarity because we know all the side lengths. So we know all the side lengths, but we do not know any of the angles, so the only one we can use is side, side, side. All right, and that wraps up section 6.5.